to July 26 LeetCode challenge. Lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. According to the definition, lowest common ancestor on Wikipedia, the lowest common ancestor is defined as two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allowed a node to be a descendant of itself. So given this root tree here of a binary tree, we want to find the lowest common ancestor of, say, P and Q. So the lowest common ancestor of P and Q, so P and Q belong to the node, parent node, of 3. Okay, and therefore 1 and 5 are the lowest common ancestor is 3. Similarly, we have lowest common ancestor of 4 and 5. Since 5 is a descendant of 5, it could be itself, and 4 is a descendant of 5, the lowest common ancestor, it will be 5. And then we have the two of the following, P and Q, so we return the root of 1, right? Or 1 is the lowest common ancestor of both 1 and 2. So our constraints are that we have number of nodes in the trees between the ranges of 2 to 10 to the 5. Each value of each node is between negative 10 to the 9 and 10 to the 9. All values of the node are unique. Another thing is that P does not equal to Q, and P and Q exist in the tree. So given all that, we could do a breadth first search or depth first search. Let's do a depth first search for this one. I'm going to use a recursion for it. So if not root, return actually. And next thing is if root is equal to P, or root is equal to Q, then return root, because that is going to return itself. And now next thing we do is do a little bit of recursion case. So say we have the left side, which is going to be assigned to L, and that's going to be self dot lowest common ancestor, and it's going to take in root dot left, P and Q. Similarly, we're going to define right to be self dot lowest common ancestor, and take in root dot right, and then we're taking pass into P and Q as well. And then we want to return the following. We'll return root if left and right else exist, I should say, or left or right. So whatever we get first, right? Basically, if this equals the value, if it exists, then we return it. If both of them are the same root, or if one of them shows up first, then that means that this node can be a descendant of itself. Let's run this code. All right, let's submit it. So there you go. So this one took a little bit longer, but it's running a big O of n time complexity, where each n is the number of possible nodes within the tree. Space complexity is also big O of a constant actually, because we just return the value of the node. All right, that's it. Have a great day, guys.